square root of 2 over 2, and then square root of 2 over 2.
All right. So once you got it, they just flip-flop their signs as they dance around. So start putting in your 45s. Molly, what are you going to get on this green guy?
Sorry, I was looking at the timer.
Middle back, middle down. So
negative square root of 2 over 2, negative square root of 2 over 2.
Right. Alrighty. Where are we? Abby, when you get there, they're hard to see. I'll circle them because I'm squishing them in here. I said right big. Alright. So Abby, when you get here, help me with it. I'm going to go over middle, down middle.
So it would be negative square root of...
Over is positive because we're going to the right.
Okay.
So square root, what were you going to say?
I was going to say the square root of 2 over 2 and then negative
Right.
that.
Exactly. Alright, do you see why that first one is positive?
Yeah, because it's x and
we
then
went,
y.
yeah. We went to the right, which is positive, and then down. Alright, so why are we doing this? Why? There must be a reason, and I told you it was a valuable thing. So now is the moment that we figure out why we're doing this. I'll take a pause for you. What kind of time are we at for the video?
7 minutes and 40 seconds left.
Okay.
So it's only been a 3-minute video.
Okay. So we'll just leave it on then. Get rid of some of this extraneous. I guess the long and short and middle, you have that somehow, even if it's just on your circle itself. All right, everyone caught up? All right. What we're going to do at this point is ask ourselves an important question, and that is, I know you already know this because we did a special triangle, but I'm going to teach you how to do sine of 30 using the unit circle. And then you will be able to get all of these in one blink of an eye. It's quite amazing. First of all, what is the sine of 30? We've already done it another way with special triangles. So we've got 1, 2, square root of 3. So what is sine of 30 when it's opposite over hypotenuse? So Allie, from the position of 30, what's opposite over? So we know in our heads that we're expecting this answer right there, right? But look on the unit circle. Do you see a quick way of finding the sine? Do you see where I could find a 1/2 associated with 30 degrees? Right there. So what I want you to do...
How do you know that one's the sine?
How do I know? Because I did it with special triangles and I found out it was 1/2. And then I look at my unit circle and sitting right there. So find a blue marker and I want you to underline that with blue.
So is y always the sine?
It is.
Okay. Oh, is y is always the sine?
It is.
Oh, that's nice.
So, and this one, the sine of 45 is square root of 2 over 2. And we've actually did that one in our homeworks. And the sine of 60 is square root of 3 over 2. And the reason this works is because side opposite divided by hypotenuse, if the hypotenuse is 1, which it is on the unit circle, do you see then the side opposite is the sine function?
So the sine of 45 is the square root of 2 over 2.
Right. And the sine of 90, your monkey math, is 1. And the sine of 120 is, or 2 pi over 3, is square root of 3 over 2. So go around your circle and underline all the second coordinates in blue, and those will be our sines. S-I-Ns. Sins.
What about for the first one?
Yeah, that one too.
It's 0?
Yeah, the sine of 0 is 0.
And then how?
All right, let's see if it works for cosine. And then we'll look around for tangent.
I just did sine.
Cosine.
And then I highlighted this just to make the point and circled them, and then I just underlined the rest of the sine.
Again, why is the sine why is the sign matching to these second coordinates? It's because it's a unit circle. The radius is 1. So when I do opposite over hypotenuse, I get opposite over 1. So side opposite is the sine. So it's the unit part that makes this work. All right, let's look at, let's see how we can find cosine. Looking at special triangles, help me, Molly. What's the cosine of 30? I want adjacent over hypotenuse.
Square root of 3 over 2.
Hey,
So
look
we,
at that.
Is that X?
so yes, it is the x. So
They're
let's do the
opposite. So
cosine.
tangent
Let's do the
that.
cosines in red and the sines in blue. So we're gonna go around in red.
Oh, yeah. I can't use that.
And just underline all the first coordinates. And then we'll mess with tangent. Where in the world's tangent going to be? If cosine is the second, and sine, cosine's the cosine's the first, and sine's the
The
second.
top one's like 1 over the square root of 3 and the square root of 2 over the square root of 2.
Say that again. Well, what would be? What are you?
It
What
would
are
be
you?
1 over the square root of 3.
1 over the square root of 3. Almost. You're really close. All right. Let's do tangent of 30.
Can we do
So-
that in a different color?
Oh, it's
too?
the opposite.
Yeah.
It's
Very
the
good.
opposite.
Good. You guys are no fun. I can't teach you anything today. All right, Hannah, looking at the special triangle, let's see if we can get where Allie is on this. Tangent of 30 is what? Opposite over adjacent. So what would
So
that
1
be?
over the square root of 3.
All right, I'll leave it Is that the word unrationalized? I'm not rationalizing it, so I'll just leave it like that. So looking at 30, where are we going to get 1 over the square root of 3?
Is it the top part of the y divided by the top part of the x?
Almost, and that would work, but it's really the sine value divided by the cosine value. So let's try that. What's the sine value of 30? 1/2
So tan equals y.
divided by square root of 3 over 2.
Isn't that the same thing?
Yeah, it is.
So you can just do the top.
Right.
So tan equals
So-
y over x.
Pardon?
It's just y over x.
Tangent is the sine of an angle divided by the cosine of the angle, which in this case, on the unit circle, that is the y value divided by the x value. So the flip and multiply, so
I like this.
1/2 times 2 over the square root of 3, the 2's cancel. So I'm sorry, tangent's not quite as user-friendly as sine and cosine, and I can't go and mark it in some color, you know. So, but somehow, how about we take a color and just at least write that out. So say tangent of an angle equals the sine, or what do we say, the second coordinate divided by the first coordinate. Or you could say the sine of the angle divided by the cosine of the angle. Whatever way you want to say it. Or some of you even made it more brief. You said the top value for the sine fraction divided by the top value of the cosine. But I'm not going to write that. All right. So, looking at your sheet, when I assigned numbers, what was it, 4.2, 8, was it 8, 9, 12, 14, 17, and 19? Would you look at those now? Because sometimes you get home and you say, I don't know what to do. So would you look at those now and tell me if you understand what is being asked of you at number 8, for example? When you get home, or you can start it actually now, or you can leave now if you'd like to go downstairs if your pastor's there.
I see what this is.
Would you? Just I want to make sure you understand what's being asked and how we can use this beautiful creature to answer the question. Hannah?
So is 9